In this part of our lesson, we shall deal with converting rational numbers to decimals, where the decimals run into infinity or are non-terminating. Before we go into solving our first problem, please note the following notation. We draw a dash on any single digit if just the digit alone is repeating itself during our calculation. However, when the repeating digits are 2 or more, we draw a dash above all the first set of the repeating digits to indicate the same. Let me show you an example to explain exactly what I've told you. Look here. We simply write the answer to this question as 25.6 and we'll place a dash on the 6. That's it. It simply means that this 6 continues to repeat. For the second example where we have 1, 2, 3 upon 99, you notice here how many digits are repeating? 2, 4, 2, 4, 2, 4 continuously, doesn't end till infinity also. So instead of writing the full number, we just write 1.24 and we put a dash to cover the 2 and 4. Running the dash from 2 to 4 simply helps us to know that 2 and 4 are the digits repeating continuously. And then for the third case, how many digits do we find repeating here? 1.235, 235, 235, 235 till infinity. So to make this terminating, you just write 1.235 and then draw a dash from 2 till 5 to indicate that 2, 3, and 5 are the numbers that continue to repeat themselves. And this is 22 upon 7, 3.142857, 142857, 142857 till infinity. So we can't write everything like that. We just have to take the first to keep it terminating. We write it like this: 3.142857. We're not going to keep repeating it. We just draw a line on top of all the repeating numbers here. And this will enable us to know that these are the numbers repeating itself or repeating themselves. Did you get that? So let's get the party started immediately. To solve the first question, which is negative 11 upon 9, all I will need to do is to draw my table for the long division method. And remember, the number you are dividing is the number that stays in. No need to bring in the negative. You can put it in your final answer. Why 9 stays outside? So first, when we divide 11 by 9, we know that 9 can go in just 1 because 1 times 9 is 9. And when you subtract this, 11 minus 9 gives you 2. 9 cannot divide 2, so that brings our decimal point right up here. Now, when the decimal point exists, it simply means we are giving 2 a 0. How many 9s go into 20? Actually, we're going to have 2 because 2 times 9 will give us 18. So, if we subtract 18 from 20, that gives us another 2. Still, we can divide, so we give it a 0. And then 9 in 20 gives us 2 again. 2 times 9, 18. If you subtract this again, you have 2. And then you have to give a 0 for 9 to be able to divide 20 to give you 2. And you will notice that this process will continue to repeat itself till infinity. So we just end up saying that negative 11 divided by 9 is the same thing as negative 1.2, and then we draw a little dash on the 2. It simply means negative 1.2222222 till infinity. Did you get that? It's as simple as that. The second example says we should solve 9 upon 11, just the reverse of this and positive this time. To do that, I'm also going to apply the long division method that I just showed you in the first example. So the divisor stays outside while the dividend stays inside. So 9 comes inside and 11 stays outside. First, 11 cannot divide 9 because 9 is less. So write a 0, put a decimal point and give a 0 to 9. How many 11s go into 90? 11 times 8 is 88. So actually we have 8 because 8 times 11 is 88. Now if we subtract 88 from 90, that gives you a 2, right? Now we can divide 2 by 11. So we give it a 0. 11 into 20 leaves us with just 1. 1 times 11 is 11. Now if we subtract this, it brings us back to a 9. To divide 9, all we need to do is to give it a 0. And 11 divided 9 leaves us with an 8. 8 times 11 is 88. Did you see some repetitions happening here? When you subtract this, you have a 2. And to divide 2, you give it a 0. 11 divided 20 leaves with you 1 again. And 1 times 11 is 11, because when you subtract 11 from 20, you have 9. And to divide 9, you have 0. 11 divided 9 is 8. And the process continues. Now, instead of continuing this process and keep going without ending, notice the pattern. You have 0.8181818181. So the number repeating itself is 81. Therefore, you can simply write your answer by saying that, therefore, 9 upon 11 is exactly the same thing as 0.81, and you draw a dash on the 81. It's as easy as that. Use the question sheet for your practice, and I hope you understand what we've just said so far. Thanks for watching as always. See you.